going on, guys? Let's do this problem right here. The question is curve sketching. So first of all, we have to state the domain for this function. So if you see, the domain can be any real numbers because you can put any x values. So domain is any real numbers, and also intercepts. To find the intercept, first of all, if I want to find the y-intercept, I have to set x is equal to 0. So in this case, if I set x is equal to 0, cos 0 is 1. Cos 0 is 1, so 1 square is going to be 1. And 2 sin 0 is going to be 0, therefore y-intercept is going to be uh, uh, so when x is equal to 0, y is equal to 1, therefore 0, 1. So this is the point of the y-intercept. Then I have to find the x-intercept. To find the x-intercept, I have to make y is equal to 0. So if I make y is equal to 0, this will comes like some cos square x minus 2 sin x is equal to 0. Now if you see, I can directly solve it because two different things, sine and cos. So I can bring everything in one form. For example, I can plug 1 minus sine square x for cos square x. So if I plug that one, let's see what happens. 1 minus sine square x minus 2 sine x equal to 0. So to arrange this one into quadratic formula pattern, I can multiply this one by negative all side. So if I multiply by negative everything, it will become sine square x plus 2 sine x minus 1 is equal to 0. And now what I can do is, if I see, I can't really, this is not a good factorable values right here. So what I can do, I can use this formula right here, quadratic formula. That's sine x is equal to minus, I think you remember, plus or minus b square root of b square minus 4ac over 2a. So I'm just, so minus b plus or minus of b plus or minus square root of b square minus 4ac divided by 2a. So in this case, we have b, that is 2. So it's going to be minus 2 right here. Plus or minus b square is going to be 2 squares, which is going to be 4, and minus 4 times a is going to be 1. So this is 1, and c is going to be negative 1. Here it's negative 1, so it's going to be times minus 1 over 2 times a, 2 times negative 1. Oh, 2 times a is this one. So a is 1, so it's just 2. Then it's going to be minus 2 plus or minus. So this is going to be 4 minus 4 times minus 1. It's going to be plus 4. Plus 4 means this is going to be 8. So this is going to be 8. Then divided by 2. Then if I solve for this one, I will get minus 2. Okay, minus 2 plus, I can simplify this one by dividing by 2. So I can say this is minus 1, and this is square root. So if we take this one out, plus or minus. So if I simplify this one, this comes out to be minus 1 minus root 2 plus or minus root 2. So it has two values, minus 1 minus root 2 or minus 1 plus root 2. So we only need one value to draw the graph. So let's take the plus value because that will be better. So if I find the value, that comes out to be, so this is sine x. Sine x is equal to this value. If we solve for x, x comes out to be 0.427 radians, and that's the x-intercept. So this is x-intercept. So in this case, in this value y is equal to 0. That's what we done here. So it's going to be 0.4270. So this is my y-intercept. Choose next step is we have to find the periodicity. So we know that periodicity of the sine x is going to be 2 pi. For sine x it's 2 pi. For cos square x it's going to be 5. And to find the symmetry, I have to take f of negative x. So if I plug negative x for these values, cos square minus x, cos square minus x, and minus 2 sine minus x. If you see this, this is a square, right? So if you square a negative value, this will become positive. Therefore, this is going to be cos square x. You can write cos square x, and minus 2 times minus x is going to be plus 2 sine x. So it's going to be plus 2 sine x. Therefore, now we have to check whether it is equal to f of x, this value. So if you see, this is not equal to this one because this is minus, this is plus, this is not equal to this one. Also, therefore, this is not even symmetry. Not even symmetry. To check the odd symmetry, I have to check whether this one is equal to minus f of x. Minus f of x. So to check, what I have to do, minus f of x means this is the whole thing is minus. So this has to become minus, this has to become plus, but this is plus, but this is not minus in the front. Therefore, this is not equal to f of minus x. So therefore, this is not odd symmetry. Not odd symmetry. Next thing is we have to find asymptotes. So first of all, let's see vertical asymptote. So to find the vertical asymptote, I have to set the denominator 0, but in this case we don't have any denominator, so there's no vertical asymptote. So to find the horizontal asymptote, I have set limit f of x, limit x approaches infinity plus or minus infinity f of x. It does not exist in this case, therefore this does not exist. And the sixth one is increase and decrease. To find that one, I have to take the first derivative. So let's take the first derivative of this one. So f prime x is going to be cos square x. So first of all, this is a chain rule. So first of all, outside derivative is going to be 2 cos x. Then inside derivative of cos x is going to be minus sin x. So it's going to be minus 2 cos x sin x, and then derivative of this one. So minus 2 derivative of sin x is going to be cos x. So it's going to be minus 2 cos x. So in this case, what we can do, we can take the, so our purpose is to find the critical values. Then only we can check the increase and decrease. To find the critical value, I had to check this, I had to set this one into 0. Also we can factor this one. So this one 0, and to factor this one I can take the minus 2x common, minus 2 cos x common. So if I take minus 2 cos x common, I will end up with sin x plus 1, and that is equal to 0. Therefore we know that cos x is equal to 0. Cos x equal to 0 means x values are going to be cos x is 0 when x is equal to 5 by 2. So when x is equal to 5 by 2, cos is 0. Also 3 5 by 2, cos is 0. So we can take those two values, 5 by 2, 3 5 by 2. And then if I solve for this one, sin x comes out to be equal to negative 1. So negative 1 means 5 by 2, at 5 by 2 sin x is positive, but at 3 5 by 2 sin x is negative 1. So we can get that point. So it's going to be 3 5 by 2. And then now we have to check the intervals. So let's put the intervals right here. So we have 5 by 2, 5 by 2, 3 5 by 2, 3 5 by 2. Okay, so in case let's take the 5 2. So okay, so let's take between 5 and see what happens. So first of all, okay, so below 5 by 2 I can take 0. So if I substitute 0 in this first derivative, what's going to happen? For example, cos 0 is going to be 1, so it's going to be negative, and sine 0 is going to be 0, so this whole thing is going to be 0. This negative 2 times cos 0 is 1, so it's going to be negative value. So this is negative, so it means decreasing. And now I have to check value between 5 by 2 and 3 5 by 2. So let's check 5. So if I substitute 5 for cos value, cos phi is what? Cos phi is 1. Cos phi is minus 1. Sin phi is 0, so we don't have to worry about this thing. And here cos phi is minus 1, so minus times minus is going to become plus. So this is plus. So it's been increasing. And after 3 5 by 2, maybe I can, okay, if I plug a value, okay, 3 5 by 2, let's see. So after 3 5 by 2, we know that cos is, okay, let's take the quarter. We know all silver teacup. So here we have in the fourth quadrant. So after 3 5 by 2, it's in the fourth quadrant. It means the cos is going to be positive. Cos is the only thing that's going to be positive in the fourth quadrant. So let's see if in this value. So if cos is positive, and if the sine is negative, what's going to, this will become positive. Cos is positive and sine is negative, this will become positive. And here if cos is positive and this will become negative. Oh, I can take 2 phi. So let's see, if I take 2 phi, what's happening? If I take 2 phi, cos 2 phi is 1, so cos 2 pi is 1, negative 1, and sine 2 pi is 0. Here cos 2 pi is 1, so it's going to be negative 2 times 1, so it's a negative value. So we can say this is negative, and I'm taking it phi. So that's where this is, we can say this is decreasing in this point. And then also from this one, we can say this is a local minimum because it's like going decreasing and increasing. So it's a local minimum. Here is a local maximum. So this is 5 by 2, and if I calculate the value of y, if I plug this value in this equation, I have 5 by 2 is going to be equal to minus 2. And also here it's 3 5 by 2. If I plug this value in this one, I will get plus 2. 3 5 by 2 plus 2. So these are the two values. So let's go to the next one. Intervals of concavity and inflection points. To find that one, I have to take the second derivative. So in this case, if I take the second derivative of this one, f double prime x is going to be equal to, so minus 2 cos 6 sine, okay, maybe I can use this one, product rule. So minus 2 cos 6 sine x plus 1. So if I take the second derivative, this is going to become minus 2 cos 6 minus 2 cos 6, and this is derivative of sin x is cos 6, so minus 2 cos 6 times cos x plus, now I have to take the derivative of this one, so minus 2 cos 6 is going to be Derivative of cos x is going to be sin x, but minus sin x, right? Minus sin x. So it's going to be plus, it's going to become plus 2 sin x times sin x plus 1. So this is the derivative. Now let's simplify it more. So let's multiply this one. So it's going to be minus 2 cos square x plus 2 sin square x plus 2 sin x. So this is simplified form. Now we have to find the critical points. To find the critical point, I have to set this one equal to 0, but this is cos square x, these two are sin x. To make everything equal, I can plug 1 minus sin square x for the cos square x. So let's see what happens. Minus 2, 1 minus sin square x plus 2 sin square x plus 2 sin x. So if I do this one comes out so to be like something like this. Then if I solve for this one, so I can now multiply these things. So this one comes out to be 4 sin square x plus 2 sin x minus 1 is equal to 0. So from this one I can create two sets of equation. That is 2 sin x. So this is factored form. So it's going to be 2 sin x minus 1, then sin x plus 1 equal to 0. So from this one I will get sin x is equal to half. Sin x is equal to half, which means there are 30 degrees. So basically 30 degree and 150 degrees. So it's going to be 5 by 6 and 5 by 6. So these are the two values. And also we have sin x equal to minus 1 right here. Sin x is equal to minus 1, which means it's sin x is equal to minus 1 is 3 5 by 2. 3 5 by 2. So these are the values, critical points for the second derivative. Now what I have to do, I have to check the increase and decrease in these points. Not increase and decrease, concave down, because for the second derivative it's going to be concave up, concave down. So in this case we have 5 by 6 right here, 5 by 6. Then we have 5 by 6 and 3 5 by 2. And let's plug a value below. So if you plug this second derivative, I directly put this one. So if you plug the values below 5 by 6, you will get negative value, and above, like between 5 by 6 and 3 5 by 6, you get positive value, and after this it's going to be negative. Yeah, so this means here it's concave down, concave up, concave down, concave up. So now we have everything, and also we know this two of them are inflex, 3 of them inflection points. So at 5 by 6, y is going to be equal to minus 104, and at 3 5 by 6 it's going to be same thing, minus 104, and for the 3 5 by 2 we calculated already, it's 2, so we don't have to write it. So I draw the graph in this. Now we are ready to go. So we can draw the graph here. Okay, let's begin with the 0. So we know the y-intercept is 0 when x is equal to 0, y is equal to 1, so it's going to be starting at 1 and going 5 by 6. So 5 by 6 and 1 over minus 1 over 4, and it's crossing this point at when x is equal to 0.427. So 0.427, it's going to be crossing there until that it's decreasing, because we know that it's decreasing until 5 by 2, until 5 by 2. So let's see, this is 5 by, if this is 5 by 2, it's decreasing until 5 by 2, and after that starting to increase. So this is basically 5 by 6 because concave down. So we have to, it has to increase at 5 by 2. Then we have to have 3 5 by 2. So increasing at 5 by 2. So the change happens when, so 5 by 2 at negative 2. So here it should be negative 2, starting to increase. Then at so until negative 2, until positive 2, it's going. So because at 3 until 3.52, 3.5 by 2, it's increasing. So this is positive 2, so it's going to be until this point. It's increasing, and we are going to have an inflection point. After that, it's starting to decrease. So this is my final graph, and that's how the graph is going to look like. And I hope you guys like this video. See you next time.